Quiz. Here's your review, guys. 144 to the 1/2 power. Don't forget, that right there is your power. This right here is your index. And you are supposed to think of it like this. Index goes there. That goes underneath the radical. And that's your power. So really, this is just a fancy way of saying the square root of 144, which is 12. Now, again, I don't want to confuse you, but we've had many problems where it's x squared equals 144, and if that's the case, it's bada boom, bada bing, do the right thing, you get plus or minus 12. But when you have the square root of a number, all they want is the principal root, which is a fancy way of saying positive. They want the positive. Now if you happen to go plus or minus, technically you're not wrong, but all they want is the positive principal root. Number one is done. Alright, so let's go on to number two. Number two, that's called our radicand. That's what goes underneath the radical. Fancy talk, just to do that. That's our power. That's our index. Now, like I said in class, you've got choices. You can go 121 cubed and then try to find the square root of that monster number. Who wants to do that? Or you can just take the square root of 121 first, which just happens to be a nice neat 11, then cube it. Let me get my calculator a second. Alright, so typed it in the old calculator, 1,331. There's your answer. Okay, number three. What are the values of each expression? Round to the nearest hundredth. Well, this is a whole different deal here. And you recognize it's a different deal because you take a look. Is there a perfect sixth root of 64? No. Do you want to go 64 to the 5th power? No. So how are we going to do this? Well, this is a calculator special. We'll ignore the negative for last. And so we're going to take our calculator, 64, and we're going to hit this little guy, raise that to the 5/6 power. Oh, it didn't take that. So 64 to the 5 divided by 6 power. Let our calculator do the work, and we get 32. Give me a second here. Alright, just going to be honest with you guys. When this said round it to the nearest hundredth, and I just looked at it, I thought it was just going to be some wacky answer, but really the sixth root of 64, if you look at it, 2 times 2 times 2 times 2 times 2 times 2, that's 8 times 8 is 64. So we could have done it that way. And so the sixth root of 64 is 2. Now we go to the 5th power, and that, because 2 to the 6th is 64, 2 to the 5th, if you take one of these off, you get 32. But that's negative 32. Now this next one is clearly why this is written. Because we got a decimal, cubed, 4th root. If I go the 4th root of that first, it's not going to work out pretty. If I go 4.6 cubed, that's not going to be pretty. Take the 4th root, it's just not. So this is a moment where you do things reverse of what we've been doing. 4.6, this is your power, this is your index. You got to know where that stuff goes, and now we've got a calculator required problem. 4.6 raised, I could put 0.75, but I'm going to stick with 3 divided by 4 power and make little squiggly lines to the hundredth. 3.14. That's the 10th, that's the 100th. This would be the 1,000th position, and that's not going to round up, so that's useless. So 3.14. All right, number 5, simplify. Remember, if we have the square root of a negative or the fourth root of a negative, if this is an even number and this is negative, that is no solution, not possible, imaginary numbers. But we have the cubic root of a negative 27. I call this numberland. So 3 times 3 times 3 is 27. But we want negative 27, so negative 3 times negative 3 times negative 3. A negative times a negative times a negative gives us a negative, and that all makes 27. So the cubic root of negative 27 is negative 3. Now we go to letterland. Here's our power. So really I'm going to rewrite this. Take that power, write it over the index, and that just reduces to m to the first. So that's part of my answer. Do the same thing with this. N to the 6th over 3. That reduces to n squared, so I stack that in my answer. Piece by piece. Number 6. Okay, so we got the fourth root of 625. Now, those of you, maybe you understand that 25 squared is 625. That might give you a hint that there might be a perfect fourth root of 625, and we would experiment and just take a look at 5 times 5 times 5 times 5. That's 25 times 25, which is 625. So the fourth root of 625, this tells us, is 4. Excuse me, is 5. Sorry about that. Now we do the division thing. 8 divided by 4 is 2. 28 divided by 4 is 7. And that would be it. Number 7. We got this 49 thing going on here. And there's some creativity going on. And a couple different ways to look at this. Student number 1 might go 49 to the 2 over 6 power. And if you just use a little math, that's 49 to the 2 6 reduces to 1/3, and that would be the cubic root of 49. Now, I might come back to this in a minute. A different student with a little bit of number savvy is going to look at that and just think, I could rewrite this as the 6th root. The 49 can turn into 7 squared, and that 2 comes along, and so power to a power I multiply, so that's the 6th root of 7 to the 4th, and then if I reduce that using my rules, that goes over this, so it's 7 to the 4th 6th power, which is the same thing as 7 to the 2/3 power. Now, this is an okay answer. What's the difference between this and this? Well, this student will notice that that's 7 squared, hopefully. I'll put that in parentheses, and then we got the cubic root of that. Now we can go power over index, 7 to the 2/3 power. Now, if this is a multiple choice test, you might be looking out for that. You might be looking out for this. And, but both of them are acceptable. Simplification. It doesn't specify whether to leave it in exponential form or radical form, so I would have to accept both of these. Okay, number 8. This one, definitely want to get rid of that 7 right away. So we get x cubed equals, hopefully this works out nice and neat, and that'd be 20. 7 goes into that, that's 14, 49, that'd be 27. Now, our goal is to get 1x to the first power equals, and then whatever we end up with, that's our answer. So how do we turn that into a 1? Well, there's really 2 ways. So student number 1 takes a look at this thing, and they think, how can I make that a 1? Just multiply that power by 1/3, then do the same thing over here, and that's perfectly fine. This ends up being 1. That's what we want. This is the same thing. Remember, that's the index. Cubic root of 27 to the first, which is unnecessary. The cubic root of 27 is 3. Now, a different student takes a look at the same problem, and you would just take the cubic root of this side and the cubic root of that side, and that will do the same thing, because these 3's cancel. And then you've got the cubic root of 27, which is 3. So, different looks, but really you're doing the same thing. This one's a little messier, so we can get rid of the 7 just by dividing. Grab my calculator. So 1,999,27 divided by 7 is this crazy 2,8,5,6,1 equals x to the 4th power. Again, we can take the 4th root of this side or multiply that by 1/4. I'm going to multiply that by 1/4, but then I got to bring that to the 1/4 power, and then I'm going to go like this: 2,8,5,6,1 raised to the 1/4 power, and I get x is 13. Okay, number 10, describe and correct the error the student made in writing the expression in radical form. This is exponential form, and looks like the student went from here to here, and then from here to here, and then from here to here. Now, I think I'm going to make it simpler and just go with our rule. This is the power of the radicand. This is the index. And it looks to me like they flipped these around, so that's what happened. All right. What is the reduced radical form of each expression? Well, again, take a quick look at this. 2 times 2 times 2 times 2. We're looking to see if that 4th root of 32 is actually like a nice, neat thing. Well, 2 times 2 is 4, times 2 is 8, times 2 is 16. So that's not the route they want us to take, necessarily. So what they are looking to do is see if you guys realize this is your power, so that's your numerator in your exponential form. This is your index, so that goes here, and now this is the same thing as 32 to the 1/2 power, and it says reduced radical form. So now we're going to take this is the square root, so we know there's a 2 there. You don't necessarily need to put it there, I'm just showing you the parts of 32. Now there's a 1 there, but we don't need it. Now this thing needs to keep going because they want the reduced radical form. Well, we got the square root of 4, 9, 16, 25, and the list goes on and on. You want to grab the biggest one that's going to make your life the easiest. So that's 16 and 2, which is 4 square root of 2. Now what if the student took the bait and they grabbed this, because 4 does go into 32. Then they would have had to go square root of 4, square root of, 8, and then they get 2 square root of 8. Now the danger is you might think you've finished, but this can keep going. So that turns into the square root of 4, square root of 2, and there's a 2 right here. Now what's the square root of 4? 2. So that's 2 times 2 times the square root of 2, which would take us back to the original answer. That's why grabbing the largest one is your best option. Number 14, we've got, remember I call this oil, and I call this water, and I call that water. So that you guys can remember, water mixes, but doesn't mix with oil. So I'm going to bring that out in the front, then I'm going to mix all the water together. So I've got a 4 underneath there, and then I've got an a cubed times a. There's an invisible 1 there, so we add. B to the 5th times b would be b to the 6th. Now, if we just ignore that 5 for a bit, the square root of 4 is 2. There's an invisible 2 there, so we can divide 4 by 2, get a squared, divide that 6 by that 2, get b cubed, And then this 5 pops back out. Now all we've got is oil. So this can mix. This comes along for the ride. Dunzos. 15. Again, cubic root of 125. We're wondering, is that a perfect cubic root? Because if it is, makes the problem a lot easier. 5 times 5 is 25, times 5 is 125. So the cubic root of 125 is 5. Then we do our division thing. 9 divided by 3, that's a nice, neat number. 3. Now I've got a little bit of work to do. Yes, that's the same thing as y to the 7 thirds, but that's not considered simplifying it. What is considered simplifying it, we take this over to the side and just analyze it. The way I taught it in class was like this. What's the first number less than 7 that 3 goes into? And that'd be 6. That would leave us with 1. Now this one actually reduces. 6 divided by 2 is 3. And now look at oil, 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 water. So we combine all our oil, a little bit of water there. That's it. Okay, so these videos upload better if they're around 15 minutes, so I'm going to stop. This is part 1.